Assalamualaikum and good day. So today we're going to start with new chapter which is chapter 2 diodes. So this one is chapter 2 part 1. So I intend to cover half of this chapter part 1. So I will name it as part 1A. So in the next video recording, I will record the remaining half of this slide, which is chapter 2 part 1B. So later on you will have chapter 2 part 2 different slides. Okay, so now without further ado, we continue, okay, with this new chapter. Okay, pen. Maybe I should use this one first. Laser. Okay, so this is the new chapter, chapter 2 part 1, diodes. Okay, so in this chapter we will learn about the p-n junction. Okay, what is the junction? Junction is the interfaces between two regions. Okay, so here if you see this, we have a p-n junction. Here we have this is p region and this is n region. So what does it mean by the p region? P region is positively charged and the majority carriers in the p region is holes. So mean it have more positive charge of hole compared to negatively charged free electrons. Opposite is the n region, which has negatively charged as negative charge as the majority carrier is the free electron compared to the minority carrier, which is hole. So here you have majority carrier, which is holes, means positively charged. In here you have a majority carrier of free electron, which make the n region become negative. So this is the explanation here. Okay, p plus n type, so you're going to have p-n junction. So p-n junction is formed when p type region is joined with n-type region, a basic structure that forms a semiconductor diodes. Okay, so this one is the basic one. Okay, later on when you learn, later on as time goes by, you will learn that there is more complex structure of semiconductor diodes. So this one is the basic one, basic structure. So this is what we call as a p-n junction. Okay, interfaces between them. Okay, so okay, how can I hide this one? Okay, so the p-n junction, with the formation of the p and n materials, electron from n type. Okay, remember n type we have majority carrier of free electrons. So when we combine these two regions, when we combine these two regions, which is the p region, okay, p region and n. So electron from n type, where we have here is majority carrier of free electron, right? So it will diffuse to here. Okay, the electron, the majority carrier, will go to here, because here we have more free electron, right? So it will go to the p region. Okay, and hole from p type will diffuse into the n type. Okay, and the hole will diffuse to n type. Okay, so this movement happens. Okay, combination of electron and hole at the junction takes place. So there will be a combination of electron and holes, because electron is going here to this side and hole is going to here on the opposite side. So there will be combination of electron and hole at the junction. So when equilibrium is reached, there is no further diffusion of electrons and hole across the junction. So the movements of electron and hole, okay, will be stopped, okay, roughly stopped when the equilibrium has reached. When equilibrium has reached, you don't no longer have diffusion. Diffusion happen when there is like a movement, right, from electron of the n type going towards the p type region, and the hole from the p type regions going through the n region. Okay, where both of these carrier, hole and electron, they will combine at the junctions. Okay, if you see, this is the junction here. Okay, the movement is p going to n, n going to p, but the combination will be happen at the junction. Okay, is the words here. Okay, so p region receive electrons, okay, and become negatively charged. Okay, when the p region start to receive free electron, right, it will become negatively charged here. Okay, and the n region, it start to receive hole, right, hole is positively charged, so the n region will lose electron and it become positively charged here at the junction. Okay, then you will have a depletion region. Okay, depletion region where there is no longer no mobile charge carrier due to diffusion across the junction, so we will have a barrier potential. Okay, this is what we call as a barrier potential. Okay, barrier potential is difference of potential between p and junction across the depletion regions. Okay, so remember, potential is due to the position, right? Remember last time we learned about potential energy, kinetic energy. Okay, potential is due to the position. Okay, so barrier potential is different of potential, okay, between p and junction across the depletion region. So it's clear. If you don't understand, you can ask me later when we have the face-to-face class. Okay, next. So what is a p-n junction? Okay, so this is review. Try to see from the previous slide. If we ask you what is the definition of p-n junction, in, let's say we ask you, in your own understanding, explain what is p-n junction. Okay, so you don't have to memorize it as long as you understand what is p-n junction. P-n junction is where we have p, a region of region which is positively charged due to majority carrier of hole, and the n region which is the negatively charged due to majority carrier of free electron. When this p-n junction is happen when these two region is brought together, okay, and form a junction between these two regions. So this is p-n junction. So explain what is the diffusion. Diffusion is what? Diffusion is the movement, right, from electron filling the p region and the hole filling the n region. So describe the depletion region. So this one we can ask you, what is your understanding, how you define it in your own words. Okay, so don't memorize, try to understand. Okay, next. So here, at the instant of junction formation, there is a surplus of free electron in n regions. So we have, when we have at the instant, here is instantaneous, means pada masa itu. Okay, at the instant of junction formation, there is surplus, ada limpahan. Okay, there is surplus of free electron in n region as compared to the p regions. That's why it is n region, right? Because it have a surplus of free electron, so it is negatively charged. Okay, as compared to the p region, because p region has a majority carrier of hole, so it will have a surplus of hole, so it is positively charged. Okay, free electron from n region will diffuse into the p region. Okay, so electron will diffuse into the p region. N region will loses free electron, so because the electron from the n region is moving towards or diffuse towards the p region, so slowly n region will lose its own free electron. At the same time, P region will also lose hole because the hole is moving towards the N regions. Okay. A pair of ions is formed near the junction. So this pair of ions just now is described by this photo. You see here, this is a pair of ions. So you have negative and positive, negative, positive. So this is a pair of ions is formed, okay, at the junction. Diffusion currents, okay, this one is diffusion currents. So let's say we ask you what is the definition of, for example, up until now you learn what is conduction current, you learn what is Hall current. The next is you learn another one that you will learn from this slide is what? Another type of current is diffusion current. So let's say we ask you what is diffusion current. So this how you should able to explain it. Okay. So diffusion current creates a layers of positive charge on the N-type regions. Okay. And also a layer of negative charge on the P-type regions. Okay. So as what you see from the previous slide. So let's see this one. We try to see this one. Ensure is cut. Let's see this one. You can play this thing when in the slide because the link is actually clickable.
AWS database services with the
Okay, we'll wait until this end. Okay, so let's we maximize them. Unmute, then let's hear. Let's listen to this explanation of formation of junction at diodes. Okay.
Junction diode, properties and uses. Formation of the p-n junction. The p-type semiconductor has an excess number of holes. Therefore, holes are the majority carriers of charge in p-type semiconductors, as shown. Similarly, n-type semiconductors has an excess number of electrons. Therefore, electrons are the majority carriers of charge in n-type semiconductors, as shown. The combination of p-type and n-type semiconductors results in a junction. This combination has many applications in electronic devices. When a p-type semiconductor is suitably joined to an n-type semiconductor, a contact is established between them and is called a p-n junction. Formation of depletion region. The p-n junction formed out of the p-type and n-type semiconductor separates p-type semiconductors from the n-type semiconductors. However, because of the contact, some of the electrons from the n side enter the p side. Similarly, some of the holes from the p side enter into the n side. So, at the junction, these electrons and holes combine with each other. The hole and electron neutralize each other on such recombination as shown. Therefore, in the region close to the junction, only negative ions are left behind on the p side and only positive ions on the n side. This results in the formation of a narrow charged region on either side of the p-n junction. The n-type semiconductor close to the junction becomes positively charged, and the p-type semiconductor close to the junction becomes negatively charged. On either side of the junction, the region D becomes free from mobile charge carriers. That is to say, on the n-type side of D, no free electrons exist, and the p-type side of D, no holes exist. In the region of D, only immobile donor and acceptor ions exist. The region close to the p-n junction is depleted of mobile charge carriers and is called the depletion region. Since on either side of the junction J, stationary positive and negative charges exist, there is an electric potential difference of Vd between the edges of 1 and 2 of D. This potential difference Vd across the junction is called the potential barrier, as it prevents further movement of holes and electrons. This combination described becomes a p-n junction diode.
Taste Galaxy.